Okay, for question number 39, it's given that the ability of a medium to refract light is expressed in terms of its optical density. Now, the optical density is not exactly as the mass density. These are two different things. And for two media, the one with the large refractive index is optically denser medium than the other. So that means if you have two media and the one with the larger refractive index will be optically denser and one with the lesser refractive index will be optically rarer. So the other medium with a low refractive index is optically rare. It's given. Also, the speed of light through a given medium is inversely proportional to its optical density. That means more is the optical density, less is the speed of light in that medium. Now, determine the speed of light in diamond if the refractive index of diamond with refractive vacuum is 2.42. So let's answer the first part. This is okay. First one. Now, the refractive index of diamond. Let's say the refractive index of diamond is ND. D is for diamond, N is for the refractive index, and it's 2.42 with respect to the vacuum. That means it's the absolute refractive index. And refractive index of a medium is given by the speed of light divided by the speed of light in that medium. Okay, so here the medium is diamond, so refractive index of diamond is equal to C by speed of light in diamond. This is the diamond. Here medium is the diamond and refractive index of diamond is 2.42 speed of light. We all know speed of light is 3 into 10 raised power 8 meter per second. So this is equal to 3 to 10 raised power 8 divided by speed of light in diamond. And if we cross multiply this, now speed of light in diamond is equal to 3 into 10 raised power 8 divided by 2.42. So this is now, if we remove the point, this is 300 divided by 242 into 10 raised power 8 meter per second. So this is 100, this is 1 to 1. Okay, so if we divide 100 by 1 to 1, so 100 divided by 1 to 1 will give me this 0.826. So this is 0.826 into 10 raised power 8 meter per second. And so this is 3 upon 2.42. That's 1 to 1. Okay, actually this is, I have calculated it. So this is 3 into 10 raised power 8 upon 2.4. Now if I remove this point, this is equal to 300 upon 242 into 10 raised power 8. And if I have to cancel this with 2, this is 1 to 1. This should be 150. Okay, now we have to divide 150 by 1 to 1. So if I divide 150, so divide 150 by 1 to 1, which gives me 1.23. So this is now equal to 1.23 into 10 raised power 8 meter per second. This is the speed of light in diamond. 1.23 to 10 raised power 8. This is 10 raised power 8 meter per second. Okay, now the next part says the refractive indices of glass, water, and carbon disulphide are 1.5, 1.30, and 1.62 respectively. If ray of light is incident in these media at the same angle, then write the increasing order of the angle of refraction in this media. So we have three media: glass, water, and carbon disulphide. So let these be three media. So one is glass, and the second one is water. Let these be the media: glass, water, and the third one is the carbon disulphide. Okay, let these be the slabs of the first one is glass, and it has refractive index of glass is noted by Ng. So glass has refractive index 1.5. This is 1.5. Next one is water, and water has a refractive index of 1.33. Next is carbon disulphide. So this is carbon disulphide, and it has, let's say it's a carbon disulphide. I'm going to denote it with C and D. So it has 1.62. So its refractive index is 1.62. Okay. Now let the ray of light. So in this case, more is the refractive index, less is the speed of light in that medium, and the greater refractive index is here 1.62 than this. So that means the carbon disulfide, it has greater refractive index than glass, and the least is in the water. So that means the least will be the speed of light here. So speed of light in carbon disulfide will be least, speed of light in glass will be less than this, and the the greater will be the speed of light in water. Okay, now so refractive index here is it's 1.62, it's 1.5, and it's 1.33. So which, because the refractive index is inversely proportional to the speed of light in that medium, so this is how exactly it looks. Now let's incident a speed of incident a ray on all ray of light on all these media. Let this be the normal, and light is incident at the same angle. So light is incident at the same angle theta. So light is incident at the same angle theta. So this is, let's say, same angle. The angle of incidence is same. This is the incident and this is the normal. This is the normal. Normal means perpendicular to that uh, refracting surface. So here, in this case, refractive index is greater, so that means the ray of light will bend more towards the normal. So let this be the refracting angle. So this refractive angle, so in this case, the refractive ray, this incident ray will bend towards the normal but will be less than this one. So this will bend towards the normal but will be less than the will bend less. So that means this angle of refraction is more than this one, this one. So let this be the angle of refraction. This is the angle of refraction R. So this is the angle of refraction. So this is greater than this. Now here the refractive index is less, so that means the speed of the ray will bend least in this case. So here the angle of refraction will be, this will bend least. So that means the angle of refraction, this. Now we have to write what is asked in the question. The question is to write the increasing order of the angle of refraction. So increasing order means that we have to write the least one first. So least one is here. So that means the angle of refraction of carbon disulfide is the least because it will bend more towards the normal. So this is less than the angle of refraction in glass, and then the angle of refraction in water. Yeah. This is how the angle of refraction looks like. So it will bend more than the angle of refraction is less, least. It will bend less than this. So this, its angle of refraction is greater than this one, and it will bend least towards the normal. So here the angle of refraction is greater. So this is the increasing order of the angle of refraction. Now the fourth one, the speed of light in glass is this, and speed of light in water. So speed of light in glass, glass is the medium, and speed of light in water is given. So more is the speed of light, less is the refractive index. So 2 into 10 raised power 8 is the speed of light in glass. So 2 into 10 raised power 8 meter per second is the speed of light in glass. So this is the speed of light in glass, and speed of light in water is 2.25. So 2.25 into 10 raised power 8. So this is 2.25 into 10 raised power 8 meter per second. So here we can see the speed of light in water is more than the speed of light in glass, and more is the speed of light in water. So that means the refractive index. So here the speed of light is less. So that means the speed of light in glass. So the refractive index of glass is more than the reflective index of water. So in this case, our option should be which one of two is optically denser and why. So we can write here that the refractive index of glass is more than the refractive index of water. So how do you write it? The speed of light in water is more than the speed of light in glass. We can write the speed, this is speed of light in water is glass. Okay, that is refractive index of glass is more. So less is the speed of light in medium, more is the refractive index. So that means the refractive index of glass is more than the refractive index of water. So that's the reason. Okay. Now, for the next question, so which of two is optically denser? We can say that glass is optically denser. More is the refractive index, more optically denser is the medium. More is the refractive index, more optically denser is the medium. Therefore, glass is more optically denser than water. Okay. Okay, now for the next one, it's given that a ray of light is incident normally at the water glass interface when it enters a thick glass container filled with water. So what will happen to the path of the ray of light after entering the glass? We have to give reasons. So ray of light is incident normally means 90-degree at the water glass interface. So there is a water glass interface means the light is entering from water into the glass. So let this be the water and this be the glass. Now let's say this is the water and this is the glass. Now ray of light is entering normally means at 90-degree. So this is how the ray of light is entering. Now this is the incident ray from water, that is, and this is also the normal. So that means angle of incidence. So angle of incidence is equal to 0 because it's the angle between the incident ray and the normal. So this ray is the incident as well as the normal. So angle of incidence is 0. So that means the angle of refraction will also be 0. So that means the light ray will enter undeviated. So light will enter from water to glass without bending. We can say that light will enter from water to glass without bending, that is undeviated, or we can say that it will go straight. And reason is because angle of incidence is equal to zero. Angle of incidence is equal to zero because the incident ray is also the normal, and angle of incidence is the angle between the incidence and the normal. So both are same. So that means angle of incidence is equal to zero, which gives us angle of reflection is equal to zero. So it will go without bending. And this was the answer for B part. So this was the B part. This was the A part, and this was the B part. I've explained this using diagram. And okay, for the next one, third one, the absolute refractive indices of water and glass are 4 by 3 and 3 by 2 respectively. So absolute refractive indices of water. So we know that absolute refractive index of a medium is given by C, where C is the speed of light upon Vm, where V is the velocity, Vm is the velocity of light in this medium. First medium is water. So refractive index of water will be C by Vw. And the refractive index of glass will be written by Ng, medium is glass, C by Vg. Now refractive index of water, this water is given which is 4 by 3, so this is C upon Vw. And the refractive index of glass which is 3 by 2, so this is 3 by 2 is equal to C upon speed of light in glass. Let this be equation 1 and let this be equation 2. Also, speed of light in glass is given, so that means this is given. Speed of light in glass is given, which is 2 into 10 raised power 8 meter per second, and we have to find the speed of light in vacuum. So speed of light in vacuum means C. So let's use this one. So here its refractive index is 3 by 2 C, and V speed of light in glass is 2 into 10 raised power 8 meter per second. So if we cross multiply this, C is equal to 3 by 2 into 2 into 10 raised power 8 meter per second. So this gets cancelled. So speed of light in vacuum is 3 into 10 raised power 8 meter per second. So we can write here speed of light in vacuum, which is also the speed of light in air. So speed of light in vacuum, which we denote by C, is 3 into 10 raised power 8 meter per second. Okay, now let's use this to find the speed of light in water. So let's use this equation. 4 by 3 speed of light in vacuum is 3 into 10 raised power 8. We have to find the speed of light in water. So let's cross multiply this, which gives us speed of light in water is equal to 3 into 3 into 10 raised power 8 divided by 4 meter per second. So speed of light in water is equal to 9 by 4 into 10 raised power 8 meter per second. And 9 by 4 is 4 2s are 8.25 into 10 raised power 8 meter per second. This is the speed of light in water, which is 2.25 into 10 raised power 8 meter per second. Okay, with this, we are done with question number 39, and this finishes this set as well. To like, share, and subscribe. Thank you for watching.